Hello, in this video we're going to begin looking at Lab 3 and looking at the multi-stage op-amp requirements. This first paragraph says, design and simulate a two-stage transistor level MOSFET op-amp. Following the example shown in figure 1.1, so looking at figure 1.1, we can see just about all the values are given, with the only exception being the load, and that's because this SPICE directive uses a step parameter. So I would pause the video and build this circuit. So now that you've built this circuit, you are most likely using these BSS84s for the PMOS and BSS123s for the NMOS. So going back to this first paragraph, it says the example uses BSS123 NMOS and BSS84 PMOS transistors. Feel free to explore the LTspice models and datasheets for these transistors to familiarize yourself with their characteristics. You don't have to use these specific models. Feel free to select a different model available in LTspice or define your own. So when I built this circuit, I also built it experimentally, and I had NMOS 2N7000s. They're in the TO92 package, so they look like transistors, and I ended up purchasing some PMOS equivalents that would work well with those. So since we're just doing a SPICE model, it's not needed, but it's a good idea to be familiar with the transistors that you are using. And so I'll pull up I built the model using the BSS84s. So what I did is I was using the NMOS 2N7000s. So what you can do is you have to search out a model, and so I already have that. I was using this 2N7002, which is pretty much just a surface mounted version, and so I found a model online, I copied it and pasted it into a text file, and then added it to the directory. So if you're running this Lab 3 original, you want to make sure this text file is in there. And so what I would end up doing, as I'll show you, is you end up changing these names. Instead of BSS123, I would just change it to 2N7002. And so you would do that for each NMOS. Okay, and now we want to create a directive, and we put dot include, spell it right, include 2N7002.txt. And then we run it. Here, let me exit out of this just to make sure it runs. We run it, and now our model works. So the problem with this is I spent quite a long time scouring the web trying to find a 2N7000 model. Well, there is an option that I found in GitHub where it adds Infineon NMOS and PMOS libraries. So this is the link, and it's important to realize what LTspice you are using. You can see there's LTspice 4, and what is this? LTspice 17. And it has very simple directions. You just download this file, take the Infineon NMOS folder and place it in your LTspice library simulation folder. So what that would look like is here. This is my PC, documents, LTspice, library. Here's my sim, and you can see I copied both of these from the downloaded document. And then you go to the subfolder, and there was this PMOS folder and just a lot of other stuff that you just copy and paste in here. And so what that downloaded file looks like is this. So there's the subfolder, you just copy and paste all of that stuff into here, and then the sim folder is much easier. You just copy those two things and place it in the sim folder of LTspice. So after you do that, what you end up doing is you pull up a component and there's these new Infineon folders. So you click on Infineon, and lo and behold, now we have 2N7002s. And so there's a handful of them. Just make sure you're using the one with 3 terminals. So I'll use this one, and I'm just going to place it there, delete all of these ones. And now we can get rid of this include, and we run it. And we have a similar result. So now looking at the PMOS, we have that nifty new folder which allows us to have access to all these new PMOS components. I know that I'm pretty sure the BS170 is very compatible with the 2N7000. I would suggest if you were to use this BSP170P to look up the datasheet. And so you could just use one of these, slap it in there. You could also just continue to use these components, but whatever components you use, make sure you look up the datasheet and become familiar with them. So I think the last thing I wanted to show in this video was, originally I ended up looking up a forum that I found this ZVP336 model, and it is compatible with a 2N7000, which that's what I had on hand, like physically. So I ended up downloading this model, and then I just copied this from the forum, put it in a directive, and then rename these transistors the model name. So a lot of this can become very cumbersome, and you can spend a lot of time trying to get models to work, especially when you're trying to use .include or .model or .lib. Okay, so I've got the model, I've got the name changed, and just to show you what it looks like, in the document, so I'm using this Lab 3 original, and this is the model. The model comes with this and a PLT file, and this is the downloaded file. And so make sure that is in your working directory, and then you just gotta copy and paste the .model into the directive, and you can run it. Oh, let me exit out of it just so you can see that it runs. Then you run it, and it works. So build the schematic, build the design from the manual in figure 4.1. Decide what device, the PMOS and NMOS devices you're going to use. Become familiar with them by looking up the datasheet, and then we will go farther into this lab in the next video. Thank you.